Hey everyone, Mr. Fritz here. We're going to talk about the length of vectors in this final video in this series of notes. And to find the length of this vector, we really, what we have is a vector of two components, 2 in the horizontal direction, 3 in the vertical direction. And I want to find the length or the size of this vector A right here. So in order to do that, we just have to refer back to our right triangle knowledge, and we have to look at the Pythagorean theorem. So this magnitude of A, and this is our notation, the magnitude of A kind of looks like absolute value, but that means the magnitude or length of vector A is going to equal, or I should say the magnitude squared is going to equal 2 squared plus 3 squared. And so the magnitude of vector A is going to then equal the square root of 2 squared plus 3 squared, which is equal to the square root of, I think that's 4 plus 9, so that's 13. So that's it. That's the length of vector A. That's the magnitude of vector A, however you want to call it. That's what that is. This is the distance from here to here. Notice this doesn't have a direction, it just has a size. And in general, we can sum this up to just say, in general, if I wanted to find, if I have some vector A and it's made up of two components, A1 and A2, the magnitude of vector A is going to equal the square root of A1 squared plus A2 squared. And hopefully this makes sense. It's just the Pythagorean theorem. So let's see an example of what this looks like. I've got 3 vectors. Some of them are resultants of other 2. And I want to find the magnitude of all of them given these starting points. So let's start off by finding the magnitude of vector S. So the magnitude of vector S is going to equal the square root of -1 squared plus 4 squared. And that's going to equal the square root of 1 plus 16. That's the square root of 17. And that's it. That's my magnitude of vector S. Getting a little bit more complex, I want to find the magnitude of vector, the resultant of vector R plus vector S. So really I want to find the magnitude of 2, 3 plus -1 plus 4. This would be the sum of vectors R and S. So I want to find the magnitude of 1, 7. And that's going to equal the square root of 1 squared plus 7 squared, which is equal to the square root of 50, which is equal to 5 root 2. That's the magnitude of R, vectors R plus S. And finally, in this third example, I want to find the magnitude of R minus S. So this is R right here, and I want to subtract S, so that's -1, and subtract 4. So that's going to be the magnitude of, this will be 3, -1, and that's going to equal the square root of 3 squared plus -1 squared, which is going to equal, this is 9 plus 1, that's the square root of 10. That is my length, or my size, or my magnitude of this vector here. So in the final example, I have a you try. You try these 3, where this time we're taking some scalar products of these vectors, but it's the same process. So see if you can't figure these out. Pause the video, and then check your answers on the next slide. All right, and here are the final solutions for these 3 problems. Notice that these 2 are exactly the same. Ooh, is that a coincidence? No, it's not, because when we're talking about size of vectors, it does not matter what direction we are in. These both have the same size, even though one is in the complete opposite direction of the other. So a size will always be a positive value, and that's quite frankly why we use these absolute value signs to mean the magnitude or the size of these vectors. So hopefully it made some sense, and thanks for watching.